Conjugate flights, 1967, where we discovered and made the first confirmed conjugate aurora in the northern and southern hemisphere for the first time. I flew on the northern route from Anchorage south to Kodiak and then back up north to the north coast of Alaska and then back to Anchorage. It was an aircraft, Los Alamos Scientific Lab, a KC-135 with a tail number of 369. Very early version of the Boeing 707. Faculty and staff at the Geophysical Institute attempted to document conjugate aurora for more than a decade prior to these airborne missions. They had good but not perfect correlations that auroras were conjugate with data from magnetically conjugate ground-based cameras and magnetometers in Macquarie Island, Antarctica, and in Kotzebue, Alaska. One can only see aurora from conjugate positions for about 2 weeks in each March or September, because at all other times the other hemisphere is in full daylight or night. The probability of clear skies or clouds ruined many previously coordinated ground-based attempts. Time for remote stations depending on being able to receive distant electric radio signals, which are often erratic due to changing ionospheric conditions. Clocks need reliable 60 hertz electrical power in those days. It was not available from the small generators. Flying above the clouds in these aircraft and communicating reliably via satellite helped ensure this effort's success. A good friend at the National Science Foundation knew Los Alamos wanted to do good science with airborne conjugate missions, previously designed to snoop on other nations' atmospheric atomic bomb tests. The National Science Foundation provided $25,000 to Al Balon at the Geophysical Institute for the first year's 3 missions in March of 1967. Neil Davis played a critical role in getting NASA to allow the northern and southern aircraft to use their advanced technology satellite system for communications, which ensured the 2 aircraft knew that they were in their magnetically conjugate positions at the same time. I was a graduate student at the Geophysical Institute of the University of Alaska Fairbanks. I was asked to fly on the northern plane. I installed the Sky camera in both planes at the Sandia Corporation facilities at Kirkland Air Force Base, which was also the Albuquerque, New Mexico International Airport. Eldon Thompson, an electrical engineer at the Geophysical Institute, was selected to fly on the southern aircraft while I flew on the northern aircraft. Our first step in preparing for flying these missions was to determine if Eldon and I had any pre-existing medical problems with our hearing or other medical conditions. Eldon had been in a United States Air Force ground crew chief for F-84 fighters without any hearing protection and had marginal hearing. My hearing was fine and proved to be good in testing. We drove to Eielson Air Force Base near Fairbanks and individually went to a small soundproof booth and donned headphones. I remember it as a rather standard hearing test, which tones were changed in pitch and loudness. I toggled the push button switch to indicate what I heard or did not hear, and the operator wrote my reactions down. Within moments of Eldon in the booth, the operator yanked off his headphones, saying that Eldon was deaf. Turned out he'd been reading lips for a long time. We also had medical flight done at Fairchild Air Force Base near Spokane, Washington. In early February, Eldon, Russ Beach, Tom Nallen, and I left the Geophysical Institute at the University of Alaska in Fairbanks and flew to Cannon Air Force Base in New Mexico. At Cannon, we had hours of instruction on how to use oxygen masks in case the aircraft lost pressurization. We were learned why we needed to purposely slow our breathing so we did not get too much oxygen into our bodies at the time with the oxygen mask. We had 2 major sessions in their explosive decompression test chamber. The chamber looked like a well-constructed and sealable shipping container with Navy ship-type doors. After classroom instruction, we went into the main chamber, and they slowly pumped the air out, simulating air pressures from the surface to about 15,000 feet altitude. During the slow climb to altitude, our instructor gave us various word and mathematical problems and worked with us so that we would give notice when we were suffering lack of oxygen. I remember the instructor gave up when it came to Ellen, who did complex mathematical problems at altitudes beyond what the instructor himself could handle. Ellen had spent 2 or 3 summers at 14,000 feet in a Geophysical Institute field camp on top of Mount Wrangell in Alaska. We entered the major explosive decompression chamber through a smaller section. And this is where we would undergo explosive decompression. Ellen and I sat across from one another in the smaller section with doors sealing us in while they pumped the air out of the main chamber. We could see the big valve on the wall above us that we knew would slam open, which would take us in a smaller chamber from 2,000 to 18,000 feet in an instant. We were to don and use our oxygen masks while they slowly brought the air pressure back to 2,000. Ellen and I were the first, and there were 2 things they did not tell us about this experience beforehand. First, we were thrown up in the air by the cushions, the foam rubber cushions that had air pockets in them. And also secondary clouds of moisture immediately formed, making it impossible for us to see one another, though only 4 feet apart. It was fun, and we did not tell the other Geophysical Institute who were following us what would happen. Everyone met for a debriefing afterwards, and we received certificates that we had successfully passed explosive decompression training and knew how to use oxygen masks. After the training was over that day, we went to a special restaurant to celebrate. It was one of the restaurants where you pick a raw steak, and they would cook you as you liked it for your dinner. Eldest told us, go ahead, they had to go back to the motel first. He good-naturedly told us that explosive rapid decompression had caused him to shit his pants. Our instructors had told us that the air in our stomachs would expand roughly 9 times and that we would fart, but since everybody was wearing oxygen masks, no one would probably know. While at Cannon Air Force Base, Gina called me to tell me she was pregnant, and I told my mom and dad right away, and she told her parents. Due mid-September 1967. At Kirkland Air Force Base in Albuquerque, I completed the installation of the 35mm all-sky cameras of both airplanes and prepared for a shakedown test flight over New Mexico. In the late afternoon, we were prepared to take off. My seat aboard the U.S. Air Force was one of 3 that faced backwards. My takeoff and landing seat was just ahead of the wings and next to the outside skin on the left-hand side. I sat looking backward opposite the direction the plane was flying, but out a window, which few did, I could see the ground. Even as we taxied along the runway, shared by both Kirkland Air Force Base and the city of Albuquerque for my first takeoff in this plane, you could not hear someone next to you talk without wearing a headset and a microphone, because the plane had so little sound dampening insulation. I could listen to almost every intercom channel aboard the aircraft, but was told under no circumstances would I like to talk to any channel except the 2 science communication channels. As we taxied, I heard the U.S. Air Force crew, pilot and co-pilot, talking with the control tower on one channel and also their chatter on another channel with a flight engineer about the readiness of the aircraft for takeoff. The plane was exceptionally heavy with all the permanently mounted scientific gear on board. The pilots applied the brakes, brought the aircraft to a shuddering halt at the takeoff point on the runway that ran towards the southwest, and started running up the engines just like they usually do on every commercial jet aircraft today when poised at the end of a runway for takeoff. They slowed the engines down and ran them up again 2 or 3 times. Then I heard the flight engineer matter-of-factly tell the pilot and tell the co-pilot that of the 2 electrical generators on each of the 4 engines, only 5 were working. He followed this with a long recitation of mechanical problems and aircraft ills. The pilot, co-pilot, and flight engineer concluded they were ready to take off, which left me wondering how bad it would have to be to call off a takeoff. Said we rattled down the runway, and then we finally The rattling stopped as the wheels left the tarmac, but we were over the Rio Grande Canyon, and then suddenly the noise in the engines dropped dramatically, and we sank so far down it scared me. The engines were still running, but it seemed to take forever because I see we were again climbing. I could see a half dozen other people aboard the plane with me all this, and they didn't seem a bit less worried. I later learned that this was one of the first 707 aircraft Boeing had built, and used water injection to increase the power output of the engines during takeoff. The water increased the density of the air through the engine, which resulted in more thrust. The sinking feeling I had experienced came when they ran out of water that they on board for that purpose. Our checkout flight over New Mexico that night was good and everything worked. So the next day we were going to fly the first of the Conjugate missions that took us west to Hawaii. Next, we flew to Beale Air Force Base in California and refueled for the night flight hop across Pacific to Hickam Air Force Base in Hawaii. We got to know the crew, Sandia crew, who flew regularly on these planes, and we knew they had years of experience, particularly in Hawaii. But Ellen and I were surprised when the Sandia folk completely disappeared after we landed and did not stay in the hotel that he and I did. They had been in Hawaii so often they had other plans. Ellen and I stayed at a hotel on Waikiki Beach and one day rented surfboards and unsuccessfully attempted to surf in 1 to 2 foot swells. I also recall handing a handful of coins to a Hawaii sales clerk in our hotel to pay for something simple like a package of gum, and have her come almost completely unglued and yelling at me for trying to trick her into accepting coins from another country. I had inadvertently given her some Canadian coins. These were interchangeable with American coins in Fairbanks, but apparently Hawaiians had to deal with coins from other Asian countries that looked like American coins but were not equal in value. I bought a couple of fresh pineapples to share with Gina after the night flight from Hickam to Hawaii, thinking we were going to land in Eielson Air Force Base, which was to be our home base. But before we took off from Hickam, I learned that our home base had been changed to Elmendorf Air Force Base in Anchorage. The Sandia crews had asked again and again about girls and nightlife in Fairbanks. As a newly married graduate student, I had nothing to tell them. We landed at Elmendorf Air Force Base in the early hours of the morning and were bused to the Captain Cook Hotel. In the lobby, this amazingly good-looking woman in her hair piled on top of her head grabbed, kissed me, and hugged me. She was Gina in a new dress, makeup, and hairstyle. She had learned of the change home base and had flown down to greet and be with me for a few days. I was planning on sharing an expensive room with someone from Sandia or Los Alamos because they, like me, had per diem for 2 people to a room. Gina was with me for 3 days, and we kept moving to cheaper rooms. I remember the last room we shared. She sat on the floor of our room in her skimpy night clothes with her hair pulled pile high. We ate fresh Hawaiian pineapple together. Gina flew back to her classes in Fairbanks, and I continued flying. Our nightly run started around 11 p.m. at 33,000 feet over Kodiak Island and lasted about 4 hours. During this time, we flew along the magnetic meridian north to Barter Island, Kaktovik, in the Arctic Ocean. Then we flew back to Kodiak before returning to our base of operations at Elmendorf Air Force Base in Anchorage. Each mission night, we flew across the width of the Auroral Oval, centered roughly over Fort Yukon, Alaska, at 2 a.m. prime time for auroral activity. We flew 2 nights in a row and took a rest on the 3rd night. That's wrong. We flew 4 missions altogether and took a day off in between. After the flight, I downloaded and shipped the film back to Geophysical Institute, and Eldon Thompson, who flew on the southern plane that was home based in Christchurch, New Zealand, did the same. Within hours of receiving the first films from Eldon and me, Al Blon, the Geophysical Institute Ranarver, got word back to us that we had successfully documented conjugate aurora. One of the nights as we took off from Elmendorf, the plane not only shuddered but seemed to stagger for several tense seconds as we left the runway. I heard the control tower tell our pilot that I had seen a huge shower of sparks as we left the ground. presumably the tail had hit the ground. I felt a hand on my shoulder and saw an urgent motion for me to get out of my seat, which I did. This was unusual, as we were not supposed to move until a pilot told us we gained enough altitude to safely move around. I watched the seat I had been sitting on quickly disconnected from the floor and thrown to one side, and a door in the floor thrown open. The man doing all this reached down and pulled up a tube assembly. It was a periscope used to look along the belly of the airplane. On some missions, it deployed the long wire antenna that trailed behind the aircraft as they flew. Now they were using it to observe, not to observe the periscope. They were looking for damage to the underside of the tail. While this was happening, the pilot circled the airport. The periscope operator declared he saw no damage. The pilot announced he was going to leave the underbelly illumination lights on so he would fly close to the ground so observers there might see, tell us whether they saw any damage. They did not see any damage, and nothing untoward had happened. They pulled in the periscope, set my seat back, and we gained altitude to start our mission. The three 1967 March missions were extremely successful and led to more conjugate missions in the coming years. During one, our low-level black and white TV system confirmed conjugacy within a fraction of a second for changes in position and intensity of weak to moderately active aurora. When activity increased beyond a certain level of conjugate, positions were modified by changing magnetic fields at the altitude of the aurora, and we're not able to keep up. What follows is a copy of a press release by the Conjugate flights issued 3 June 1967 by the University of Alaska. On the southern aurora, similar experiment shows. On the evening of March 11th, an instrument-laden KC-135 jet took off from Anchorage towards the Aleutians and turned around and started following a precisely plotted path extending from Cold Bay northward across Alaska to Fairbanks and Fort Yukon. At the same time, 7,000 miles away, a similarly equipped KC-135 departed Christchurch, New Zealand, and flew southward toward Antarctica along an equally precise path. The two planes were part of a unique experiment performed by the University of Alaska Geophysical Institute that disclosed a high degree of similarity between the austral, so the southern, and the boreal, the northern aurora. For 100 years, scientists have known that both the aurora and the southern exist and auroras occur frequently, but no one knew whether the auroras in these two regions were similar. A clue arose from studies of the data taken to International Geophysical Year 1957-1958, which showed that the northern and southern hemispheres had roughly similar characteristics. Many scientists expected that some similarities should exist. The energetic particles from outer space which strike the atmosphere and make it glow, creating aurora, are guided along the Earth's magnetic field lines. These magnetic field lines radiate out from the Earth in a series of gigantic curves, which intersect with the Earth's surface at 2 points called conjugate points. Since these field lines guide the particles causing the aurora, some scientists thought the observers stationed at 2 conjugate points would see identical auroras. In recent years, however, most scientists studying the aurora have believed that the magnetic field lines would become so distorted and weak at great distances from the Earth that they could not guide the energetic particles very well. Consequently, most theories predicted that even if auroras occurred at the same time at the two ends of the magnetic field line, they would not be identical. Recently, Professor Al Balon and Director Keith Mather of the Geophysical Institute were awarded a grant from the Office of Antarctic Programs of the National Science Foundation to examine the question of auroral conjugacy in more detail. They cooperated with Dr. Neil Glass of the Los Alamos Scientific Laboratory to equip 2 Atomic Energy Commission KC-135 aircraft with all-sky cameras and photometers with which they could measure the location and brightness of auroras. Flight paths over conjugate points in Alaska and south of New Zealand were determined with the aid of a high-speed computer. Checkpoints and times were calculated to ensure that the aircraft would be over the points at exactly the same time. Shutter synchronizers acting to 1/100th of a second were connected to the cameras to activate them in both planes at precisely the same time. Timing was a critical point in the planning because the conjugate points were in different time zones. Only a few hours of darkness were available during which the auroras could be photographed. The experiment could be done only at the equinoxes, March or September, when the length of night is roughly the same in both hemispheres. A test flight from Mexico to Canada was carried out successfully in February. By early March, preparations were completed for the equipment experiment. William Nikiforenko, Neil Brown, Ellen Thompson, and the Geophysical Institute were assigned to operate the all-sky cameras and photometers on the airplanes. Missions were flown on March 11th, 13th, and 15th. The auroras were detected on all three flights. During the flights, the scientists discovered they had intermittent radio communication between the two planes. Discovered they had excellent communication. This contact enabled them to adjust their flying speeds and courses more precisely to ensure the two planes flew over conjugate points exactly on schedule. After the missions, films were carefully processed and then collected at the Geophysical Institute for comparison and analysis. The project was successful beyond all expectations, Institute officials reported. The photographs showed conclusively that the southern and northern aurora at identical. Final analysis of the films is being completed and the results will be presented at a major international conference in Switzerland this summer. Professor Ballon said it was a tight schedule and perhaps a long shot, but it paid off. The results are bringing us one step closer to an understanding of the mechanisms through which solar particles are caught by the Earth's magnetic field and accelerated into the atmosphere to cause aurora. Other flights with different equipment are planned for next year to further improve the findings. After the conjugate flights, I returned to Fairbanks to continue teaching the Physics 104 class. Another graduate student, Paul Perot, had taught my Physics 104 class for me while I'd been away. I earned the wrath of Professor Minnie Wells, who was thoroughly disgusted that I'd been doing other things and not writing as I'd been agreed to do. She wrote a blistering memo saying she would no longer help me because I was not trying. Some of the energy of her memo was directed at the Geophysical Institute and Al Ballon, but most fell, as it should have, on me. Writing well has remained a difficult thing for me to do all my life.